to our weekly series about Python. So, in as part of our series, we like to discuss about how we can utilize Python to solve real-time business scenarios, and we're going to continue our discussion in that. Okay. And the discussion that we are going to have today is going to be related to the process of EDA and data preprocessing, and we're going to explore the world of automation. Okay. So once we get to that point where we have some automation available to us, or where we have some kind of automated process, we will discuss it in more details. Now, quickly, we will remember everything that we have covered so far. We have looked at our business understanding, objectives, constraints, success criteria. These are critical. Now, people might think that it is not important or it is not relevant, but it is extremely, extremely important that we get this done, right? Because if you do not understand your business problem, you're never going to be able to solve any real-time scenario. Remember, your job is not just to build the best algorithms, just use the latest techniques. No, the job is to create real-time solutions to real-time problems, right? And that is what we are aiming for. So business understanding, data understanding, all of these are very important, right? Then afterwards, we looked at some of our data and we explored the data a little bit. We understood some of the columns. We replaced some values. We did some basic descriptive statistics for our numerical as well as our non-numerical or our categorical features. Check for null values, we check for categorical values, and we also visualized our numerical and categorical columns. So I'll just quickly rerun these cells. Okay. So wherever we think it is important, we'll run them. So we were able to visualize our categorical as well as numerical data quite well, as you can see here. And this kind of visualization aims to please the crowd. And that is also important in terms, because maybe you might feel like the information that you're getting is not relevant. But trust me, every single piece of information is relevant. Now, we are going to focus today on two very important things. The first half, we will deal with our outliers, because outliers are a major hurdle that you'll face when it comes to dealing with any kind of data. And in the second half, we will take a look at our pipeline. Okay, and we will try to understand how we can create different data pipelines, pre-processing pipelines, or EDA pipelines for further analysis. Now, we created a box plot last time. So let's wait for the visualizations to come up. So there we have it. Okay. We have created some visualizations. Okay. So now in this, we can identify the columns which are outliers. Okay. Now, one of the things that we need to look at here is the shape of the data, the distribution of the data. Okay. So for example, let's compare two columns. Let's take education, or let's take age. Let's take capital again. First of all, we can see clearly the shape of the data, right? But when it comes to capital gain, it's quite obvious that our data is not having a sufficient value for variance. The same applies for our capital loss. Okay, if we compare it with any of the other columns, we can easily identify where we have the actual outliers or where we don't have the actual outliers. Okay. So what we want to do here is we want to process the information that we have based off of this fact that we have just established. So we have already created our box plot. Okay. So what I want to do here is I want to create a list. Okay. So I'll call this columns to remove. Now, in this, we will take two columns. We will take our capital loss and capital gain. These are the two columns that we have. Okay. Then I'll take another data frame. I'll call this outliers data frame, and I'll say this will be I. We'll use list comprehension here. I for I in columns underscore to remove if I not in the I for I in what was our value? Numerical features. Yes, we want to take the numerical features. I for I in numerical features if I not in underscore calls to remove. Okay. So this way we are going to create a list of values which are supposed to be treated for outliers. Okay, so these are the columns where we want to keep the outliers values. Now, the next thing that we need to do is we need to apply winsorization. Okay, so when we apply winsorization, we have to take a look at the library that we want to use. Okay, so we will get the correct library in our value in our code here. So we will take from feature underscore engine, which is the library that contains our winsorizer dot outliers. Import winsorizer. Okay. No module named feature engine. The solution here is quite simple. We can simply just say pip install feature underscore engine. So this way it will install that library for us. So this may take some time, this may not take some time. It just depends on your environment setup. Okay. We'll wait for it to install the necessary packages. Then we will run the code again, and it is working. Okay, so as simple as that. Right, and then the next thing that we need to do is we need to set up our winsor. So I'll call this winsor. This is equal to winsorizer, and now the parameters. The first parameter that we have is the capping method, which is IQR. So we want to use our interquartile range for capping. Then tail both left and right, because we have outliers on both the directions. Then variables. The variables will be the outliers DM. Okay, whatever values that we have in the outliers DM. So we have set up our winsorizer. Now, the next thing that we want to do is we want to fit this winsorizer on our data. Now, fitting the data winsorizer or fitting any method on the data versus applying it on the data are two different things. Fitting will do the calculations for us, but it does not affect the data until transform is done. Okay. So we'll say winsor dot fit. Okay, and we have df. We are taking at the outliers df. Okay, so did not close the brackets properly. Let's see. There you go. So then we will take outlier here. Okay, and you can see the Vinserizer method has been applied here. Okay, on which columns as well. Yep. Then simply we will transform the data frame. Now here what we are doing is we are only transforming the columns which need transformation. Okay, everything else is fine. Okay, so we will take this outlier that we have created and we will use it to transform our values here. Okay, this is done. Then what is the next thing that we need to do? The next thing that we need to do is simply apply our pre-processing steps. Sorry, before we do the pre-processing steps, let us just simply get the outliers checked out. So we will take our outlier values, okay, and then we'll do the plotting here. What kind of plot we want? We want a box plot. Okay. Do we want any subplots? Yes, we do. Then sharing is false. And figure size is, we'll take some random value, something like what we did last time. Okay. So this is going to define our axis for us. Then within the axis, we need to take a look at each and every plot that we are going to create. Okay. Subplot dot set xticks labels. So we'll set the labels for our x value, and we are going to use the subplot again to get our x tick labels. Okay. One of the best ways in which you can improve your programming skills is by actually typing out the codes yourself. Even if you are looking at it from a different source, right? You don't necessarily need to write the code completely by your hand, but the better, the more you do it by your own hands, the better it is. Okay. So this will just help you get some practice and you will start remembering things. It's just the same way in which we used to memorize things in the school, right? We would look at, we write down the values, we write down the things with our hands, and this is how we do it. Now, the next thing that we are going to be looking at is very, very important. Okay. So I'll take some space here. Now, okay, we will be looking at something known as pipelines. Okay. Now, pipelines is what we will be using for automation. Okay. Automation is, it's not just a buzzword anymore. It's something that is actually a realistic, achievable dream. So when we are talking about our pipelines, when we are talking about our automation, we want to make our lives easier. Now, we saw this entire process of outliers, where we try to identify outliers, tag them, then process them, fix them, replace them, delete them, whatever process you do, right? Now imagine every time new data comes into the picture, you have to do all of these steps. Now, maybe when we are looking at small data, maybe we are looking at data that is not a very regular occurrence. It is fine. But what happens when the data that you're looking at is actually updating very fast? You're looking at something like maybe live data source. So a lot of data is coming into the system very quickly. At that time, do you think it is possible for us to manually sit here and do all of these processes? Now, there are certain ways in which we can automate things. One of the classic ways is using object-oriented concepts, creating functions, creating classes, and then calling those classes as per the need. But what if people have come up with a different way of doing this automation? A way of doing this automation that does not involve learning complex programming syntaxes. Now, not everybody is born a natural programmer, and not everybody can pick up programming at the same rate. So, what if we had a way in which we could simply create pipelines with a few lines of code so that in the future, no matter what data is coming into the picture, we are able to process it without having any kind of manual intervention. Okay. Take an example here. Let's say that I would apologize for my writing in advance. Okay. So let's say that this is a water well or a tank, whatever you want to call it. Okay. And this is your house. Okay. You have to travel certain distance every day and come back that same amount of distance every day for water, for all of your daily needs, from taking a shower to using the restroom to cooking, anything at all, washing clothes, washing dishes, everything. You have to travel back and forth. Now, there is a limit as to how much water one can pick. Okay. Even if it is maybe just a 5 minutes walk, 5 minutes to go, 2 minutes to fill, 5 minutes to come back. Well, do it 5 to 10 times a day. You're looking at over an hour. And it's not like every time you go and do the same process, you will have the same level of enthusiasm. Repetition is a great way for us to lose interest in anything that we actually want to do. So, what we want to do here is we want some way in which we can get the water directly. So, what I do here is a very, very ingenious, a very, very simple technique. On my house, I add a smaller tank. Okay, perfect. Now, all I have to do is in the morning, I will take 1 hour. I will go back and forth and I will fill this tank up. And I can do this, maybe twice a day and be done with it. Okay. Now, I don't have to make multiple trips in the sense that I don't have to go at different times of the day. Instead of going every 2 hours, I'm going for 1 hour and consolidating all of it. Okay, sure. Right. Some sense of automation has come into the picture. But what if we had a way of, I don't know, let's say, building some kind of connection from here to here? A direct connection, maybe electric, natural, maybe this is at an elevation. So you don't need to actually do anything aside from just, make sure the direction is right. What if we could do this? What if we could build a water pipe? Okay. What if we could build a water pipe to pull the water for us? So suddenly now what happens is all of your requirements for the changes that you want to make or how much ever water you need, everything is coming for you directly. First of all, it will be faster than you can ever be. Okay, you can get higher quantities at a faster rate and lesser times. That's the magic, right? That's the magic. So, in this scenario, what can we do? We should try and build some kind of pipe here for our data. Okay. What we will do here is we will create a series of pipelines. Okay. Let's imagine that this is our data. Now, entire data doesn't have to go into the pipeline. It doesn't have to be a linear process like this. No. Right? We have the option of having a higher degree of flexibility. Okay. Let's say that this is our pipeline. This can go directly here, and this can go directly here. This can go here. And here again, we will have some kind of consolidation of whatever changes we have made. So this can come here, and this can also come here. So now it's not a linear flow anymore. Okay. The flow of the data has suddenly changed. And because of this change, our processes have become automated. Okay. So let's see how we can create these pipelines. Okay. So first of all, we need to decide on what kind of libraries that we need. So let's get into it. The first thing that we will do here is we will take whatever libraries we need. So we will use scikit-learn or sklearn as it got. From this, we will take our standard scaler, which is used for data scaling, as well as one hot encoder, which is used for encoding the data, right? Basics. Then we will also use something known as the column transform, which will apply changes to a column. Then we will take some imputation technique. Okay. And then finally, we will take our pipeline. Okay. These are the libraries that we require for creating a pipeline, at least in this specific use case. In your use case, you might not need this many or you might need more. So it's a highly situational thing. So based on the situation, you can make the adjustments. Okay. So now we will start creating our pipelines. Excuse me. We have two pipelines that I want to create. The first is the numerical pipeline. So for our numerical data, we will have a different pipeline. So here I'll call the pipeline function and I will mention the steps that I want to take. So what are the steps that I want to take here? The first step is imputing. I want to do imputation. So I'll take my simple imputer. And within the strategy, You can mention mean, median, mode, whatever it is that you want to. For this example, I'm sticking with mean, basic, whatever steps that we perform. Okay. Then this is the first step that is written. Okay. Then the next thing that we want to do here is, so here should be in brackets, so it is understood by the system. Then the next value that I want to add here is my scaling. I want to scale the data to ensure that it is unit free and all the values are in the same range. So I'll take my standard scaler and we will close the pipeline. So here I can move it like this, so it is easier for everyone to understand. This is my parentheses. Put it in the order. Yeah. Then similarly, we will take a categorical pipeline. So we will create pipeline for both our categorical as well as our numerical data. So we'll take cat pipeline. And here we will create our pipeline. And I'll mention the steps that I want to undertake. The steps that we will take, again, categorical values can also have missing values. Right? It's not, there's no hard and fast rule that categorical values must not have any missing values. They are also values. So here we have to create a strategy that is capable of dealing with them. So we will take our simple imputer, and in the strategy, I will mention most underscore frequent. It means that we will take the most frequent value. Okay. And then what to do next? We will do the encoding. Okay. So one hot encoder. And here I will pass one more parameter to ensure that my pipeline actually has a smooth flow of data. And that is handle underscore unknown, which I will call as ignore. Just ignore the value here. Then we will close everything. And that's it. It's as simple as that, right? It's as simple as that. Now, what I will do here is I will create a preprocessor variable which will contain my column transformer. The column transformer is responsible for actually making the pipeline work. So here, I'll say transformers, and it is equal to, first we have our number pipeline, numerical pipeline, which will take the numerical, will take the num pipeline variable, and it will do it on the, what's the value that we called here, num features. So we will apply our num features here. Okay. Then next, I'll take my categorical value and I'll apply the cat pipeline. And we will take the categorical features here. Okay. And that is how we are going to define our column transform. Okay. Then how to make this work? Okay. Before we apply the transformer, we will do one step. We will drop the income column in the X variable. Okay. BTF done. Then in my Y, I will take my income column. Okay. And I will use my lambda function. Okay. So lambda x. And I want to say one if the value of x is greater than 50k, else 0. So I'm splitting my data into x and y. Then the next step that I will do here is I will get my train test split. So I'll split my data into train and test from sklearn dot model underscore selection. We will take our train test split. Okay. Then the next step that I want to do here is I want to split my data. Obviously, I want to split the data, right? So I will take x underscore train, x underscore test, y underscore train, y underscore test. And we will take our train test split. Okay. And we will take our x and y. And we will say that the size of the test data is 20%, which is a standard process that we follow. So if you want, you can quickly check what each data is having. So these are some of the values that our X train is having. Similarly, I can also check Y train. Okay, this is 26,048 rows. And this is also 26,048. Okay. So then on my X training data, okay, I will apply my preprocessor. Okay. So we will take our data, okay, whatever is the name given here, preprocessor dot fit underscore transform. So I want to fit and transform it on X train. Okay. Like I made a mistake here. Yeah. The simple spelling mistake that has caused us this problem. Okay. And we can take a look at our extreme. Okay. So it has been created into a sparse matrix. Okay. If you want, we can try and see. We can print it. Okay. There you go. So that's it. This is just, you can check the shape, which is actually a best indicator of whether the pre-processing has worked or not. Okay. And finally, we will do the same process for our X test. Okay. We will take our preprocessor and we will transform the test data. We will get the same shape. Okay. So this is how we will be creating our pipe. So we'll stop here for today. And thank you so much everyone for joining. And I hope to see you guys the next session where we explore model building. Thank you all.